So this is the Electrochemical Cells lab. We've got 5 parts. Part 1, we're going to be using lead as our standard electrode, and we'll be measuring the cell potential of our 5 metals, including lead, 6 metals, and their 1 molar solutions against each other, against lead initially, as we'll measure all those. Using that data, we'll be able to put together a table of reduction potentials. There will be 6 items on the table. And then from that, you're capable of making predictions, calculating cell potentials that you might expect by comparing any of the other combinations. Instead of just lead to iron or lead to copper or lead to silver, you can go silver to copper or silver to magnesium or zinc to iron and make some predictions based on the reduction potential. So that'll be part 2. We'll cover all possible scenarios there kind of quickly because there's a quick way to do that. Part 3, 4, and 5 will all use the micro weld plate right here as tiny little beakers, and we will use these metals as electrodes in our little setup so that we've got essentially a miniature version of what we might otherwise do with a couple of beakers and a salt bridge. This uses a lot more chemical, takes a lot more time, takes a lot more glassware. So we, it's kind of a classic design for an electrochemical cell, but it also can be done in smaller scale with the large piece of filter paper here. I'll show you that in a moment, but also with these weld plates. So we'll take advantage of those smaller scale opportunities to do these labs. So the first thing we're going to do is fold this into 6 places. Got several sheets of the paper here, but I don't need all of it. So put some of that back here. We first want to fold it in half once. I'm going to get the halfway point by kind of folding it again, but not creasing it. Just kind of getting where the center point is. Then I'm going to open that back up, and I've got a little template here for a 60-degree spot. I'm going to slide that right into the midpoint. Now I'm going to fold over on this, then fold over again, and slide that out. And so what that has done is given me 6 wedges, if you will. So when I open this up all the way, I've got 6 parts. We're going to then cut into the parts there and create 6 arms. You don't have to be real creative about this, but alright, there you go. So there's our 6 quadrants. We're going to have to label each section. So I'll just go around the horn here. This will be silver right here. This will be zinc. This will be copper. The order really doesn't matter. This will be lead, Pb. This will be iron, Fe. And this will be magnesium, Mg. And now we got to clean the metals. So silver doesn't really require much cleaning, so I'm going to give that one a pass. Put that where it needs to go. Here's our zinc. Definitely should give zinc a bit of a rub. I've got some paper here that we're going to clean on. And by the way, to verify these metals here, zinc and iron look pretty similar, but iron obviously is magnetic. So I've got a magnet here to test that. Lead is very easily identifiable because it bends very easily. And copper, of course, is easily recognizable by its color. And zinc is not magnetic. It's one of those two light gray ones, but it's not magnetic. And magnesium is in magnesium ribbon form, so it's usually skinnier than the rest of the metals that we have. These are all about 1 centimeter wide. And then the silver, a little bit skinnier in the samples that I have, but it's obviously more silver in color than the zinc is when it's coming out of storage. So I'm going to clean up the surface of the zinc. You always want to do, this is emery cloth, and you always want to do this on a piece of scratch paper so you're not scratching up the surface of the lab table, your lab report, or in this case my kitchen table. Alright, so that's our zinc. I'll put that to the side. I'm going to go rinse that in a little bit. Here is our copper. We want good contact on both the top, where it's going to come in contact with the electric, the lead to the voltmeter, but also on the bottom where it's going to come in contact with the solution. Later, just for thoroughness, let's go ahead and clean the silver up. This is pretty thin, so I'm just going to rub this in one direction instead of back and forth. This is more like a foil. Here's our lead. Let's do lead last because of the lead dust. This is our iron. Definitely should clean this one because this oxidizes quite readily. Rust. I'm not a lefty here, but try a lefty here so you can see essentially what I'm doing. Alright, enough of that. Iron. Magnesium definitely needs a clean. Magnesium's a fairly active metal. Again, it's fairly thin, so I'm going to do this in just one direction. And our lead. Alright, I'm going to go clean these off. And the emery cloth because it has lead dust on it. I'll wash my hands. And I'm going to throw this paper away. So I'm going to fold this up. Throw that away. Be right back. Okay, all cleaned up. Using the filter paper as the reservoir, as the beaker, if you will, and we're going to just soak the solution into that surface. I'm going to put my piece of copper on top of there. So now we've got a half cell right there. So that's the copper. I'll set that in the back, and then we've got the zinc. And the chunk of silver. There we go. All right, so what we're going to put in the center is our salt bridge. Salt bridge is going to be a potassium nitrate solution. And so we'll open that up. Just using a dropper, we're going to pull this out, and it will be used all around the inside here to make a connection along each of these lengths. And now any one of these half cells is in contact through solution soaked into the filter paper with any of the other half cells. We're going to set our voltmeter to DC volts. 2 volts should do it. I think we're going to get maybe 1 or 2 measurements through the course of the lab where it's greater than 2 volts, and we might have to bump it up to 20 volts to read that one, but most of them will be less than 2 volts. You should be able to see that okay now. Okay, so we're going to record the voltages. The black's going to be on the lead in each of these cases. So I'll swing that around and keep the black on the lead back here. And you want to press firmly so you're getting good contact between the lead and the lead. Notice the lead and the lead, the same spelling, different pronunciation there. And then also good contact with the lead and the solution below. So the first one, we'll follow this in the same order it is on the data table, is lead versus silver. So here's the lead and here's the silver. And there's your cell potential, 1.136. We don't need to keep letting it bounce around. We'll just get them pretty quick. So here's the lead versus the copper. Lead and copper, 0.640. Lead and iron. Here's the iron. Negative, notice the negative, negative 0.042. Here's the lead versus the magnesium. Negative 1.277. Here's the lead versus the zinc. And that is negative 0.40. It's jumping around quite a bit. Let's try that again. Negative 0.415. There we go. And then let's go ahead and do, just for good measure, we should be able to predict what this is, but lead versus lead. And that is 0. Okay, so write a 0 down for that. So what you're going to do with that information is, from the data table, you're going to create, just to the right there, a table of reduction potentials. Organized the same way that we have a table of reduction potentials in our textbooks. The most likely to be reduced, the most positive number should be at the top of that table. The most negative number should be at the bottom. Lead, the 0 value, should be somewhere there in the middle. So you're going to want to write the half reactions as reductions and then write the reduction potentials, including the sign. In part 2, and then we use that table in the lab report on the back of this first page. We use that table to make some predictions. But since we've already got this all set up and it's wet and everything, we're going to go ahead and measure all the possible cell potentials. So I'm going to start going across the first row. So I'm going to have the black connector on silver. And then I'm just going to go to each of the 5 metals, and you're going to write those down as I go. So the black connector will be on silver. And then I'm going to follow the sequence as indicated on there. So black connector on silver, and then copper, negative 0.531. And then on iron, negative 1.246. And then on magnesium, okay, that one won't read, so let's go ahead and set that up to the 20 volt mark. And then silver, silver is negative 2.56. Switch that back. On the zinc, negative 1.698. And on the lead, negative 1.248. And copper, we've got the black lead on copper. And then we're going to go to the silver. That is 0.560. Then on the copper, that's 0. We don't have to do that one. Then on the iron is negative 0.724. Then on the magnesium, got to get that one back up. Negative 2.06. Then on the zinc, negative 1.12, negative 1.20. And then on the lead is negative 0.713. Then the black on the iron, I'll come around this way. The black on the iron, the red on the silver is 1.310. Red on the copper, 0.738. Red on the magnesium, negative 1.368. Red on the zinc, negative 0.431. Red on the lead, 0.026. 0.028 is fine. Okay, black on magnesium is over here. And red on silver. Red on silver, 2.69, positive. Red on copper, over here, also high. 2.13. Red on iron, 1.390. Red on magnesium, no, we don't have to do that one. Red on zinc, 0.898. Red on lead, 1.413. Okay, black on zinc. Switch hands. Black on zinc. Red on silver, 1.809. Red on copper, 1.223. Red on iron, 0.478. Red on magnesium, negative 0.914. Red on lead. Oh wait, I skipped one. Red on, okay, I don't have to do zinc. Red on lead is 0.506. And the last row, lead, we already did this one because that was our first one where we had the black on the lead, but we'll go ahead and run them real quick anyway. Black on lead, and then we go to silver. That's 1.328. And then we go red on copper, and that's 0.737. And then we go red on iron. That's negative 0.03233. Write one of those down. And red on magnesium, negative 1.420. Then red on zinc, negative 0.527. And then lead, we don't have to do lead on lead, that's 0. Okay, I think I got them all. I hope I did. If I didn't, I'll fill them in a text or something, you know, a text block or something like that. Okay, so that's it for that part. I'm going to clean this part up.